So hi everyone, I'll take you through the Tensorflow class, which is it's part 2 of what we introduced in the first class. And with Tensorflow, this is a framework that we use in our programming classes. And Tensorflow is an open source library or framework that is designed to make it easier for you to program your deep learning models, making it faster and as well as easy to use. And one good thing about TensorFlow is that it accepts a variety, a diverse set of data sets. It can be images, it can be text, it can be numpys, data frames, and so on. So this tutorial will also cover how you can use TensorFlow with Keras, and Keras is just an API. It makes it a lot easier to use TensorFlow without just TensorFlow itself. So, and TensorFlow is a product of Google, and you can also use PyTorch. If you don't use TensorFlow, you can also use PyTorch. So, but in this class, we just use TensorFlow. So one thing about TensorFlow is that TensorFlow, the basic data structures of TensorFlow is tensors, and these are multi-dimensional array. You can take an example. If you have an image, RGB image, a colored image, it will have like 3 channels, the red, green, and blue channels, and then each channel has a pixel value. So operating such a multi-dimensional array becomes easier when you're using TensorFlow, and easier as well as faster. And if you're using even these hardware accelerators such as GPUs, CPUs, it even becomes faster because it will allow some parallel programming. Okay. And if you haven't installed TensorFlow on your system, you can use pip install to install TensorFlow from your terminal, as well as if you're using Anaconda, Jupyter Anaconda, you can create a new environment. Let's say you create a new environment, call it TensorFlow, and then you can install the TensorFlow, Keras, and matplotlib packages. These are the packages that we're going to use when you're doing the example. So in my case, I'm using Anaconda, so I have 2 environments. So this base environment is when you want to use some machine learning pandas, numpys, and also on the simple machine learning. So you can use this one. But if I want to use TensorFlow, I've created a new environment I've called it TensorFlow. And within TensorFlow, there are packages such as the installed packages. Let's say TensorFlow. I have the TensorFlow. In my case, it's version 2.6. And TensorFlow is in, and also I have Keras. Another thing is, so let me share it so that you can see also from my Anaconda screen. So I have installed, I have TensorFlow installed. I have TensorFlow installed here. And its version is 2.6, and my Python I think is 3.9. And also have Keras. Keras installed. I have Keras. So this is the API that it's also 2.6. And I have another library which I'm going to use is matplotlib. So you need to have, so that you may be able to follow through the coming tutorial, you need to have this library. So I have the matplotlib library, and this version is here. So make sure that if you're using Anaconda, to make it easy and so that you don't get errors. So sometimes I've experienced this. Sometimes you can install TensorFlow using the pip install, and then it doesn't install right. So I'll also include another video to how to set up your TensorFlow in Anaconda. Yeah, I'll include that so that it makes it easier for everyone who is going to maybe face difficulty when following through this tutorial. So make sure that you create a new environment. If you don't have TensorFlow already, you can create a new environment, call it TensorFlow. Then from TensorFlow is when you can start installing these packages. Make sure that you have TensorFlow, you have Keras, as well as matplotlib. Those are some of the 3 packages that we will use in the coming tutorial of our image classification. And then when you're, and another thing, if you're using TensorFlow now, you need to make sure that you switch to the TensorFlow environment when you want now to use TensorFlow. And make sure that your Jupyter is installed in your So you switch between the TensorFlow, you can switch between TensorFlow and depending on what you want to work on. So if you're working with TensorFlow, make sure that you switch to the TensorFlow environment, because this uses a different kernel, and it's kind of it's a resource intensive library, so it has a different kernel from the base. Yeah, so that's just what I wanted to show you when you're using Anaconda. I believe some of you will be using this, and some also use Colab. So with Google Colab, make sure that you have all the libraries installed and everything before beginning following through in the coming tutorial. So another thing that I want to talk about is yeah. So like I said, TensorFlow uses tensors as the basic data structures. These are multi-dimensional arrays, and with TensorFlow, there's this tf.data, which is the input pipeline that we'll use to when we're reading images from the hard disk. And then if you want to do some transformations, if you want to iterate over that data set. So for instance, you have your images here, like in our case, you have our images in a hard disk, and our image classification will have two classes, healthy and not healthy, meaning that these leaves, these are tomato leaves, tomato crop leaves, and some of them are healthy. There's a class that has healthy images, and the other class has not healthy, meaning that they're affected by a virus. So with TensorFlow, it will group, for instance, if you have like 1,000 images, it's easier to work with a data set with 1,000 images. But in case you have millions of images, it becomes difficult. So that's when TensorFlow becomes really helpful. So TensorFlow will group your images into a batch. Let's say if you have 20 million images, so the first batch, maybe let's say it has 2,000 images from both from this data set. So then now it will be grouped into, like if you use scikit-learn, you have split into train and X-train, Y-train, Y-test, like that. So with TensorFlow, it will have a special data structure that will group these images. And that data structure will have the two classes, the Y-train and the X-train. I mean, the Y-train for healthy and not healthy images, depending on this data set. And now, this X-train will have the tensors now, the tensors. So this special data structure is what we call tf.data set, which it is an API, and the tf.data is the API, and the special class, the data set. Then from this is when you can fit your model. So it becomes really easy. If you have a RAM, let's say of 8 GB, so if you feed all those 20 million images, that's a lot for your RAM. So when you use TensorFlow, it becomes easier because it will group those images in batches and then process the batches. And if you're using hardware accelerators like GPU, it has this prefetching mechanism that if one image is one batch is being processed, another batch is also being loaded. So it becomes really faster. It's when you are working with TensorFlow. And this tf.data API, what it does is actually it does the three things. You come across something known as ETL. Extract, it will extract the data from your, like if you are having data in your hard disk, it will extract that data. And then it will transform, is when you have some transformation, maybe converting it into mini batches, and this is inspired by these languages like C# or Java or Scala. So it will transform your data. You can use it to transform your data. You can do a lot of shuffling, mini batches. There's a lot of data augmentation or transformations that you can do with in this part. And then the other thing is that it will load your data into a specified memory. So with this, you can it allows the sequential access, and like you can iterate over your data set. So it's sequential access of those images that are within your data set. So this is really about tf.data API, and that is what we're going to use in our class. So we'll have these images, and we'll have it will list our files, then we'll do some transformations, then we'll load it, and it will I believe it's going to be easy for you to understand when we're working with the practical example. And then, yeah, so for now, just understand that tf.data data is an API that you can extract your data, help you extract your data from a disk. You can perform some transformations, as well as it can load the data into a specified part of your memory and allow the sequential accessing of that data. And yeah, so we need to go to add. I want to show you in the programming now how this can be done. And like I said, I'm using Jupyter Notebook and I've installed my TensorFlow environment. So let's, yeah, we just go to, yeah. So let me say stop sharing, then we can switch to our Jupyter Notebook. So we're going also to proceed I'm going to proceed to show you how you can you can do some of these. You can use the TensorFlow input pipeline, the tf.data to read files from that are stored in your disk, as well as you do some simple work. You can even split if you have your data set, you can split it into training and testing or validation data sets. So let's begin. So the first thing that you have to do is import, you need to import the TensorFlow library. So import TensorFlow. So that's one thing we're going to use. So import TensorFlow as here, as usual, as what we do as TF. Then after that, we're going to like list, get to know what is in our data set, the image data set that we have. Now, so let me call it image data set. Okay, so the image data set. So we're going to use tf.data data set, and we're going to use the method list files to list the number of the files that are within our data set. So we're going to use the list files. So now the list files, so we're going to specify where our data set is. So in our case, let me share, let me see. So here is our data set. So this is our data set. It's in a folder called folder 1. And with this folder 1, that's we have a data set here, and it has the tomato health images as well as unhealthy images. For our case, it's labeled as tomato yellow leaf curl virus. So these are the images that have this virus. So there are two folders within this, two subfolders within the folder 1, within the data set. So we're going to read these folders. So what we're going to do is, let me go back to where we are. So yeah, so it's within the data set, and so it's within the data set, and that's what I do, because it's within the data set, and then there's other subfolders. So we're also going to read the images from those subfolders. Then from here, I don't want any shuffle, so I'll say shuffle equals to false, so that you can see that you can see these images. They won't be shuffled, but you can read these images. So this is so if I run this, let's say just run it, and then we can actually print this. So we can use the for loop to print this the file path. Actually, this will just display the file path that these from this data set. So I'm going to use the file in image dataset from this file. So for file in this one here, I want to print them. So by it will take a so if I do this, it will print all the data sets. So I don't want to print everything. So what I'll do, I'll use the take. I just want to print like, let's say 5 or let's say 10. So I'm going to use the take method in TensorFlow, which is going to limit the number of files that are going to be listed here. So let's say like I want just to list 10 of them, and then you can print. So for this, for files that it will take only the first 10, and then so I'm going to print files. And one thing you should note also, so we're going to print we're going to print the files, and this is going to print then it is going to list the file path. Okay, so this is going to list the first 10. So that's the use of the take method. It limits the number of files that are going to be displayed here. So we can print that. So you can see that it is printing the file path from the data set. There's tomato health. So it's printing only the first 10. These are not shuffled because here I said shuffle is equal to false. So it just prints the first 10 file paths of those images. And then one thing else you should note that if I want to shuffle it, so if I want again to shuffle this, because for this case it's just printing the first 10. Now if I want to shuffle the data set, just shuffle it, and then you can do other object processing from there. So let's say that the image data set, I'm just going to shuffle this the same data set. So image data set, I'm going to shuffle this. So this and I'm going to specify the from the documentation. One thing else you're supposed to know from the documentation, it's you need to specify the buffer size if you're shuffling your objects. So one thing about TensorFlow, the data it has you can see this. It tells you what this image data set, what it takes, what's the buffer size. So the buffer size specifies the number of the items that will be in that buffer. So if you say 32, means that 32 images will be filled into that buffer size. So yeah, so image dot this is shuffled. Now we're shuffling, let's say our buffer size is just 500. I've just kept 500. Then we can even print this, and you can see, you can just use the same thing. So for file this one, you can see that it's going to print in image data set. You also take it just print 10, and then you can do that. So you can see that these are shuffled. The first case was just the file with tomato healthy. The first 10 were displaying, and this one is shuffled. Some of them are tomato health, some are this. So that's the way you can use these functions and methods in using the tf.data API with dataset as the tf.data dataset being the main class. And so yeah, so this is shuffled. We can also do in TensorFlow. Maybe if you're using scikit-learn, in scikit-learn, it's you can use the train test split method to split your data set. So in TensorFlow, you can also use the take actually to split your data set. So if I can say like if I'm splitting our data set. So you see how it becomes easier now. Now, because I've just started, this is a simple example. When we are working now with the whole data set, you'll see how this is easy. So splitting our data set. For instance, we want to split your data set. Let's say our train size, the training size of the data set. I want training size to be, let's say we want our training size to be 80% of the data to be for training. So we need to specify the training size of our data set. So even before we split our data set, we can list our class names, because we have seen that we have two classes. Like I said before, we have the class with the healthy tomato leaves, as well as the tomato with this tomato yellow leaf curl virus. So we can list our class names. Again, let me add another. We can list our class names here. Let's say that class names equals to it's a list of our two classes. The first class being the healthy leaves, the tomato healthy. I can just copy this because that's the name of the class. So this is the first class, and corresponding to the two folders. And the next class is the ones that have the virus, tomato leaf curl virus. So I can just copy the whole name. Yep. So yeah, so this is the whole, these are class names for this case of this data set. And then we can also get the length of our data set. So for this, we can get the length of our data set. So let's say we can, so the length of our data set, it's equal to length of this image data set. So this is, we want to get the length of this data set. So we're going to get the length of this. Let me store it in a variable. Let's call it data set count, so that it stores in the variable set count equals to the length of our data set. So it will get the length of our data set. So yeah, we can, I can also print it. So I want to print our data set count. To give us the, we want to know the length of our data set before even we split it. So yeah. So let's split it. Yep. Sorry. So this is the length of our data set. So it has 2000 images. And now we're going to split our data set into, we want to get the training size as well as the validation size. When you have a data set of 2000 images, you want to split it before start working with it in the model. So we can say that we can say like 80% of our data set will be used for training. So, and our data set is already shuffled. So it's going to take the 80% from all that, the data set. So we can say like it's 80% of the image. So 80% of the data count. So like say it's 0.8. So you can say like data set count, this data set count times 80%, 0.8. Okay, so size, sorry. So size is equal to this, and I want it to be an integer. It gives me a whole number. So I'll put this int. So you can run that. So again, so this is 80% of the, we want to get the 80% of the. So again, we want now to get our training data set. So let's call it training. We'll store it in a variable called training ds. Train ds is equal to, now we're going to, so that we want to get the 80% of the data set. Our whole data set is this image data set. So we're going to get, we want to get from this image data set, we're going to take only the trained size, meaning that we're going to take only this. So if so we're going to take this. So you can even print length of the, so I can print length of this trained data set. So you can see, if I print this. So let me run this. So it will tell me that it has taken 80% of this, 80% of the whole image data set. So it's 1,600 images as our training set. Then we can also get the validation data set. So let me call it store it in a variable called validation data set. And from this validation data set, we're also going to take Now we're going to use the skip. So what it does is that it's going to, it's the opposite. It's more like the opposite of the take method. So it's going to skip the first 80% of these images in that data set, and it's going to skip. So for the validation, it's going to skip the first 80% of that data set and take the remaining 20%. So instead of take here, it's going to be skip. So, and then I can print also the length of this, length of the validation data set. So yeah, so these are some of the things that we're going to, so from the 1,600 images are going to be used for training, and for the validation, you can even specify even the test data set. It's going to be 400 images. So this is just to show you what TensorFlow, the input pipeline, can do. It takes in data, you can do a lot of transformations. This is just simple, but you can do a lot of transformation using this input pipeline. Just remember, you can do a lot of shuffling, converting it into mini batches, and so on. So this is just in short of what the TensorFlow input pipeline is all about. And thank you. In the next class, now we will work on the whole data set. We'll know how to, like, after reading these images, now we will start training our model and so on. So the next becomes the fun part, actually. So yeah.